Okay, a few of you had reasons you couldn't come to class this week, and that's fine. But this was one of those labs where we didn't really follow something by the book. We just did something with a fair amount of instruction on my part in class, and so for those of you who weren't there, I decided I would go ahead and make this little Esri Hydrology sort of primer video on the lab for class skippers. So the things that we talked about was all the different tools in ArcGIS, and of course you can go down the list in the hydrology toolbox and see what they are and what they do. But there was a handful of them that we're going to need because we're going to calculate two really common compound topographic indices, the topographic wetness index and the stream power index. Topographic wetness index is just like this text here says, if you take the time to read it, and you can see what it is. The thing that you need to pay attention to here is it's an index model, and TWI at any given point is I, or the index value, equals the ln of A divided by tangent B, where I is the index value, A is the upslope contributing area, or the flow accumulation raster, and B is the topographic gradient, or the slope. Now, this says tangent B. If you calculate slope as degrees, you have to throw in the tangent function to convert degrees of slope into percent slope. If you calculate percent slope, you don't have to worry about the tangent part of the equation, and you can simply remove it. All these are calculated off of the digital elevation model, not just any digital elevation model, but a digital elevation model that has been filled so there are no sinks. So the way this works is you're going to take a DEM, fill it so there's no sinks, calculate the slope, calculate the flow direction, calculate the flow accumulation, and then do some raster calculator functions where you calculate the natural log of slope divided of the upslope contributing area divided by the slope. And I'll talk more about that as we come along. Stream power index is roughly similar to the topographic wetness index, but instead of dividing by the slope, it multiplies by the slope. And the way this works out is the steeper the slope, the stronger the current, or the stronger the force, the stronger the erosive potential of the stream. And so the stream has more power. Its power is a combination of two things. One, the area contributing the water, and two, the relative change in elevation, or the slope, which then imparts force and strength to the water. So here's what we're going to do. Extract part of a DEM, generate the required products, calculate a TWI and an SPI. We're going to do it on Jefferson County, and I strongly encourage you to do it in ArcGIS Pro. So first things first, go to Blackboard and download the data. I've already found you a nice digital elevation model that includes Jefferson County, where I want you to do this at. I recommend you do it in Pro, but you could do all this in ArcMap as well, but ArcMap's more crash prone with something like this, and the instructions will speak directly to Pro. Speaking of which, here's what you're going to do. Start off by creating a blank project. Once you've created a blank project, insert a new map, add the data that you extracted earlier from Blackboard. It's like the file, raster file that you need to actually add in is like GRDN40W something or other. That's the one you need. Now, once you've added that in, what you need to do is extract part of it because it's just too much there. So if you look along the left edge, about 2/3 of the way down, pick an area no more than 1/8 of the size of the entire DEM. Smaller is better. At 1/8 or so, it should be relatively easy to do, but once you start calculating the flow accumulation, if it takes more than 4 or 5 minutes for the calculation to run, then you need to stop, go back, and extract a smaller area. So how do you do this? Well, we'll talk about it on the next slide. Alright, so here's what you do. In the catalog pane in the database folder, find your database and right click, new, create, new feature class. And once it does this, you give it a name. You then open up that folder, click on your new feature class you just made, and drag it over and drop it on your map. Once this happens, go to the top of ArcGIS Pro to that ribbon that runs across and find the Edit tab and click on it. And once you do, the Create Things tool will emerge and basically be where you can click on it. And then you want to click on it, and when you do, it's going to open up this Create Feature box, just like the catalog pane kind of a thing, but it'll be the Create Features. And you're going to select that blank feature you just made in catalog, and select the little rectangle tool to make a rectangle. Go to that place I mentioned before, 2/3 of the way down, somewhere between the 16th and an eighth of the size of the total map, and or the total DEM, and that's where you're going to make your little rectangle. And then as soon as you've made it, you're going to save it and stop editing. And after this point, you can go to the Analysis tab. And where's that at? Back up top on that ribbon, find Analysis, click on it, and as soon as you do, you'll be able to click on the Tools tool on the ribbon. And the first tool that you're going to look for is one called Extract by Mask. It's in Spatial Analyst, for those of you that are wondering. And you're going to run that tool, which will then extract just a tiny bit of your DEM, the size of your polygon you just made. But you need to give it a new name. I called mine Tiny. So once you've made this new tiny DEM, there's a handful of tools that you're going to have to run that you're going to need for the other two layers. And here's what you're going to do. On the left is the tool, on the right is what you're going to run in it. Starting with the Fill tool, you're going to take your tiny DEM that you made and you're going to run the Fill tool, and it's going to go through and identify any sinks or low spots or depressions in your DEM and fill them up so that they all drain somewhere. Once they've done that, you'll now have a filled DEM. Once you have the filled DEM, you're going to calculate slope. Make sure that in the options you find and set it to % slope, not degrees. And then once that's done, you'll have a slope file. Again, run the slope on the filled DEM. The next tool that you're going to look for is flow direction. And flow direction, you'll again run that one on the filled DEM. And that's going to give you flow direction. Next tool is flow accumulation. The flow accumulation is built off of the flow direction raster that you created the step above. So it runs on the flow direction raster. Now, once you've got all these things, you have all the stuff you need to calculate a TWI and a SPI. So how do you do it? Well, to calculate the TWI, you're going to find your raster calculator. And on the right, there's a whole list of math functions that you can scroll down through. And somewhere down there on that list is the ln, or the natural logarithm function. When you do, it pops up the ln function and gives you a set of parentheses with the cursor in the middle. And then it's just like all the other Esri GUIs, and you double click on something, it throws it in there. Now once you double click on the first thing, it has a tendency to move your cursor outside of those parentheses, and you'll need to move it back in, because just like it shows here on this second bulleted point, your equation will be something like the ln of, and then you'll have your set of parentheses, and inside those parentheses you need to have your flow accumulation raster divided by your slope, and then run it, and voila, you now have a topographic wetness index. The next step is to calculate a stream power index. Same scenario, same tools, same kind of equation, except in the parentheses following the ln, or the natural logarithm function, instead of flow divided by slope, it's flow accumulation multiplied by slope. Do that, you now have both of them, you're good to go. All you got to do is take those two elements and put them together and turn them in. So at this point you're done. Take your screen grabs, put them in a single document, save it as a PDF, and upload it to Blackboard. And if you have any questions, come in during office hours, give or take. It's between 3 and 6 on Tuesday, Wednesdays, and Thursdays. And come in a little bit before class, and I'll be happy to help you figure out what it is that you're having trouble with. Have a good weekend. Bye.